So today we're going to move from our conversation of ellipses to hyperbolas. Hyperbola is defined as a set of all points in which the difference of distances from two fixed points is constant. So you'll notice in this picture below that if I take from the two foci, which are the 2 points in question, and measure to any point on the hyperbola, that the difference of d1 and d2 is going to be a constant. It just so happens that it's going to be 2a. A picture of where this hyperbola comes from relative to the conic section is over on the right. If I slice the two cones vertically, I'll get this hyperbolic figure. A couple of distances I need to let you know about. The distance from the center to the vertex is a. So distance center to vertex is a. B is the covertice again. So the distance from center to the covertex is B. And then you'll notice there's a focus once again, and the distance from the center to the focus is C. So you'll also notice that in this case, C is actually longer than A. So the relationship between A, B, and C is now changed. We now have a relationship stating that C squared equals A squared plus B squared. And it's not necessarily true that the A term is bigger than the B term either. Just, in fact, in this case, it kind of looks that way, but it's not necessarily going to be the case. Now, I have two axes of symmetry in this case. On the vertices, you will always have what's called a transverse axis. And its length will always be 2a. When I'm talking about my covertices, we're going to have what's called a conjugate axis. Which will always have a length of 2b. Sliding into a little clearer slide. Here's an example of a vertical transverse horizontal conjugate. There's my foci. Here's the relationship between A, B, and C. If I have a vertical transverse axis, notice vertical transverse corresponds to an up and down hyperbola. Horizontal transverse corresponds to a sideways hyperbola. And in this case, the general equation changes. I have y minus k squared over a squared minus, that's the thing that's different in this case, x minus h squared over b squared is equal to 1. Vertical transverse, up and down opening, and you'll notice that the y term is the positive term. Horizontal transverse, sideways opening, the x term in this case is the positive term. So that's how you tell the two apart. And once again, A is not necessarily bigger than B, but you'll notice A is always under the positive term. Special kind of, not trapezoid, excuse me, special kind of hyperbola is an equilateral hyperbola if A squared is equal to B squared. Just some definitions. So we're going to start by sketching a hyperbola. Again, sketch doesn't have to be super accurate, but you got to have a general idea. So I know that HK goes with X and Y. The A term's always first, so A is equal to 4, B is equal to 2. I'm going to go to my center, which is 3 over, 2 down. Put a dot there for my center. My vertices are going horizontally because my x term is first, so I'm going to move over 4 in each direction, put a dot, and then I'm going to go up and down 2, put another dot, and what I've done is I've defined where my two axes end. Now what I'm going to do, if you look in our first picture, or even our second picture, you'll notice there's this rectangle created, and the edges of our vertices and co-vertices make up that rectangle. So let's go back to this picture and draw in, if you will, this little rectangle guy. And through that rectangle, I'm going to draw some asymptotes that go through the vertices of the rectangle. These asymptotes are going to define how wide my hyperbola gets. I've already stated that my vertices go horizontally, so we're moving out from the center, and that's where my hyperbola is going to emanate from, if you will, and it will approach these asymptotes but never cross. Again, just a sketch. Now we're going to find the vertices and foci of the hyperbola. So in this case, I'm going to draw 1 under that first term because it has to have some kind of a fraction with it. My a term's always first, so a is equal to 1 and b is equal to 7, and you'll notice in this case that a is not bigger than b. Since y is my positive term, I know I'm going to have a hyperbola moving up and down like this. So I'm going to start sketching this out again. And you'll notice that my x value of the center is -1, my y value of the center is -7, like so. And there's my center. From here, I'm going to take and move, since I'm under the y, up and down 1. And that will get me my vertices. Then I'll move, actually I don't even need to move over. I know this is my a value, and I'm going to be going up and down this way. I don't have to necessarily graph this, I just have to find the vertices. So since I'm going up and down 1 and I had a center of -1, -7, and I'm traveling up and down 1, that means I'm adding and subtracting to my y value. So my vertices are going to be at -1 and then -7, and I go up and down 1 from there, which gives me -1, -8, and -1 and -6 is my two vertices. To calculate my foci, I need my c value. And I know that in this case, c squared equals a squared plus b squared. Well, I know that my a squared is 1, my b squared is 49. Thus, I have 50 equaling c squared. So, I have 5√2. Actually, is that right? 25 and 2 is 50, yep. 5√2 for my c value. And I know my foci is going to be somewhere inside that hyperbola. So again, I'm adding to my vertical component of the center. So for the foci, I go over -1 and down 7, and to that I add and subtract the distance from the center to that focus value. So that's 5√2. and I can leave that as such. Let's go to the next example. We're going to find the foci of this figure. Very similar to the last problem, except once again, I'm not in the standard form, so I'm going to have to complete the square, and we do that similarly to the way we did it with our ellipses. We're going to take and group x terms and y terms together, and then we're going to take the constant term over to the other side. In order to complete the square, we're going to have coefficients of 1, which requires factoring. So I pull the 9 out, and I'm going to pull a -4 out, which leaves me with y squared minus, that's going to be important, 8y equals -197. Complete the square, so I'm going to take half of 10 and square it, which gives me 25. And half of 8, the negative type, square that, and I get 16. I'm going to insert those in here. I have to balance the sides of my equation, but I know I'm not just adding 25 and 16. I have that multiplication of the 9 to the 25 and the -4 to the 16. So 9 times 25 is 225, and that -4 times that 16 is -64. So what I have now is I'll have 9 x plus 5 quantity squared minus 4 times y minus 4 quantity squared is equal to -36. By definition, I need to have that equal to 1, so I'm going to divide everything by a -36, thus giving me a 1 here. 36 and 9 are going to reduce nicely, but it's going to go to a negative. And I'll have a 4 on the bottom. -36 and -4 reduce nicely, once again, but it's going to go to a positive. I get a 9. So, putting this in the proper order, I get y plus 4 squared over 9 minus x plus 5 quantity squared over 4 is equal to 1, which means since the y is the positive term, again, I'm going to have an up and down hyperbola. My center for this hyperbola is going to be at -5 and -4. That's my HK value. And I'm going to need to find my C value. I have my A value, or my A squared value, if you will, of 9, and my B squared value of 4, and I know C squared equals A squared plus B squared. So I know C squared is equal to 13, and C equals √13. Now all I have to do is add vertically and vertically to my center to get my 2 focal points. So if I'm adding vertically, then my foci are at -5 and -4 plus or minus √13. And there are my foci. Another example, let's say I've got the foci and the vertices and I'm looking for the equation. Again, I'm going to sketch this out. Here's -1, let's say 2. Put a dot there. Call this 5 and 2. Put a dot there. Call this 4 and 0. Dot here. dot here. And this is a hyperbola. So if here's my foci and here's my vertices, I know this hyperbola is going to open sideways, which means that when I start writing my equation, my x term has to lead. So I know that right now. Now it's going to be important that I have my center value, which is dead center in between these two guys. So I'm basically looking for the center of 0 and 4, which puts me at 2. So I have a center at 2, 2, which means now I can start filling in my equation with my HK values. I know my A value is the distance from the center to a vertex, and that is actually 2 as well. And since A is equal to 2, A squared goes under the leading term, so I have a 4 here. Now all I have to do is find my B value. And what I have at this point is I have an A value and a C value. C is the distance from the center out to a focal point. So that ends up being 3. So therefore, if C squared equals A squared plus B squared, then I have 9 equals 4 plus B squared. And B squared ends up being equivalent to 5. So I'll put that 5 over here, and now I have my equation. Last example of the day. We take and write the equation having these foci and a transverse axis of 10. Well, we know our transverse axis is 2a, and if 2a is equal to 10, then a is equal to 5, which is going to help. My foci values are 5, 6, and 5, negative 12. Let's call this 5. Call this 6. Call this negative 12, if you will. And these are my foci. So I know the hyperbola has to open up somewhere in between these. Given that, I can then say that since this is opening vertically, I have a y value leading. And I should be able to find my center by just finding the midpoint of the two foci. So between the two foci, I have a total of 18. Therefore, half of that is going to be 9. And if I move 9 down from 6, I'm at negative 3. So at 5 over and negative 3 down, I have my center. So I move over 5 and down negative 3, and that's my HK. We've already stated my A value is 5, so 25 is A squared, and the A always goes under the first term. And once again, I'm back to finding my B value, so C squared equals A squared plus B squared. A squared we said is 25. B squared we're looking for. C we know to be 9, so C squared is 81. Therefore, if I take and do the subtraction, I end up with, what is that, 56 is equal to B squared. So I can just put that value right here. And then the problem's done. And like I said, that's our last example. And fill out these questions for tomorrow. Notice you've got an eccentricity example in this problem, and eccentricity once again is C over A. All right.